Welcome to Circles Part 2. In Part 1, we discussed the definition of a circle, and we saw how to write the equation of the circle if you're given some information about that circle. In this video, we're going to start with the equation, and then we're going to be able to state some information about the circle. Here are the two forms of the equation of a circle that we talked about in Part 1. We have standard form that looks like x minus h squared plus y minus k squared equals r squared, where the center and radius are just looking at you. And we talked about general form, where everything is multiplied out and set equal to 0. In this video, we're going to start with both of those types of equations and see what we can say about the circle itself. So let's begin with this example. I hope you see that the equation is in standard form. So the center and radius are just looking at us. Notice how this is our h and this is our k. So the center for this circle is 17, 1. And the radius is equal to the square root of the constant that's on this side. So the square root of 9 is 3. And we have this one complete. Let's do another one. Again, our equation is presented in standard form, so we can, by observation, see what the center is. Notice right here that we have a plus instead of a minus, but we know that that's really equivalent to x minus negative 4 squared plus y minus 7.3 squared equals 27. So we see that the x coordinate of the center is negative 4. So if it's in standard form, we'll take the opposite of the number that we see right here. So it was negative 4, comma, positive 7.3. Now the radius is the square root of the constant on the other side. So we take the square root of 27. But as always, we need to present our radical in simplified form. Since 27 is 9 times 3, it simplifies to become 3 square root of 3. And this one's complete. For this next example, we'll state the center and radius of the circle, but additionally, we're asked for the x and y intercepts for this circle. So let's get started. Notice it is 3x squared plus 3 times the quantity y plus 5 squared equals 21. Because of these 3's right here, it's not in standard form. So let's just divide both sides by 3 and put it in standard form. So we'll divide the first term by 3, the second term by 3, and the 21 by 3. And let's simplify, so we have x squared plus y plus 5 squared equals 7. And now our equation is in standard form. Notice we can state the center. It will be 0, negative 5. Because those are our h/k values. And the radius will be the square root of the constant, so it's the square root of 7. And the square root of 7 can't be simplified, so that's finished. But now let's find the x and y intercepts. If you recall, for any graph, if you're finding the x-intercepts, you always set y equal to 0. So I would have x squared plus 0 plus 5 squared equals 7. If we simplify, we have x squared plus 25 equals 7. So we have x squared equals negative 18. And if we take the square root of both sides, notice we do have a non-real number. The square root of negative 18 is 3i square root of 2. But we can only graph real numbers when we're drawing a circle in a plane. So there are no x-intercepts. Now let's look for the y-intercepts. We let x equal 0, so I have 0 squared plus y plus 5 squared equals 7. So that's equivalent to y plus 5 squared equals 7. Let's take the square root of both sides, putting our plus or minus in. And we have y plus 5 equals plus or minus the square root of 7. Or y equals negative 5 plus or minus the square root of 7. So let's look at this information and see what that tells us about the circle. Let's draw a rough sketch up here. Now my center is at 0, negative 5, so let me put that right here. Now the radius is the square root of 7. So as a decimal, the square root of a 7 is approximately 2.6. So from this point, oops, I erased it. So from this point right here, I will go up 2.6 units, down 2.6 units, to the right 2.6 units, and to the left 2.6 units. And I'll do my best to draw a circle that goes through those points. So now let's come over here and look at this. We saw that there were no x-intercepts, and you can see why. The circle didn't have a radius long enough for the circle to reach the x-axis. Now we do know what the y-intercepts are. They are negative 5 plus the square root of 7, so that's right here. Negative 5 plus the square root of 7, and negative 5 minus the square root of 7. And I hope that's not too much of a surprise since we saw that the radius was square root of 7. Let's do another problem. We'll state the center and radius of the circle. The equation is x squared plus y squared plus 6x minus 2y plus 7 equals 0. Notice this time it's not in standard form, it's in general form. But in general form, we can't see what the center and radius is. So our job is to transform this equation so that down here, we'll have an equation that is in standard form. So we're going to take the steps that we need to take this equation and transform it into something that looks like this. We'll notice we have a nice perfect square here, and we now have a nice perfect square here. That's going to require that we complete the square with respect to x, and we complete the square with respect to y, much like we do when we complete the square when we're solving a quadratic equation. So let's get started. I'm going to rearrange the terms so my terms with the x are together and my terms with the y are together. So I will rewrite the equation as x squared plus 6x plus y squared minus 2y. And I'm going to subtract 7 from both sides, so it equals negative 7. Notice I rearranged the terms and I subtracted the constant. I don't want that constant to be involved when I'm completing the square. Now let's figure out what numbers do complete the square. I look at this coefficient right here. Half of 6 is 3. 3 squared is 9. So 9 is the number that completes the square. So I'm going to add 9. But if I add 9 to the left-hand side, I need to make sure I add it to the right-hand side. Now let's look at this coefficient. Half of negative 2 is negative 1. Negative 1 squared is 1. So I need to add 1 to both sides to complete the square. Since I chose the appropriate numbers, I know that I will have a perfect square here. It is x plus 3 squared. And I'll have a perfect square here with respect to y as well. And I have y minus 1 squared. On the right-hand side, I do the arithmetic. I have -7 plus 10. That's 3. And notice this equation is now in standard form. So let me erase this down here. I don't need this anymore. And I can just state the center and radius. My center is -3, 1, and my radius is equal to the square root of 3. And I can't simplify the square root of 3, so this problem is complete. For this next example, we'll find both the center and radius and the x and y intercepts for this circle. Our equation is again in general form, x squared plus y squared minus 10x plus 4y minus 11 equals 0. Let's begin by putting it into standard form so that we can state the center and radius. So let's rearrange the terms in the equation. So I'll have x squared minus 10x plus y squared plus 4y equals 11. So again, notice I left space for the constants that I want to add, and I added 11 to both sides so that the constant is on the right. So let's find our constants that we need to complete the squares. So right here I have a coefficient of -10. Half of -10 is -5. -5 squared is 25. So let's add 25 to both sides. Half of 4 is 2. 2 squared is 4. So we'll add 4 to both sides. So our equation becomes x minus 5 squared plus y plus 2 squared equals 40. So let's state our center. Our center is 5, -2. And our radius will equal the square root of 40, which we know we need to simplify, and that makes it 2 square root of 10. Now let's move on and find the x and y intercepts. So remember, to find the x-intercepts, you set y equal to 0, and to find the y-intercepts, you set x equal to 0. Let me mention that you can choose to use the equation in general form or in standard form when you're going to find those intercepts. I'll just start with the equation here in standard form. So let's do it. I'm finding the x-intercept, so I'm setting y equal to 0. So I have x minus 5 squared plus 0 plus 2 squared equals 40. That gives me x minus 5 squared plus 4 equals 40. Let's subtract 4 from both sides, and we'll have x minus 5 squared equals 36. When we take the square root of both sides, we'll have x minus 5 equals plus or minus 6, and add 5. So we have 5 plus or minus 6, which we can simplify and make x equals 11 or x equals -1, just by adding 5 plus 6 and subtracting 5 minus 6. So as ordered pairs, those are 11, 0 and -1, 0. To find the y-intercept, we'll do the y-intercepts. We'll do something similar. We'll put in 0 for x. So we have 0 minus 5 squared plus y plus 2 squared equals 40. That's 25 plus y plus 2 squared equals 40. Let's subtract 25 and take the square root of both sides. So we have y plus 2 equals plus or minus the square root of 15. This time I can see that the y-intercepts will not be rational. Our x-intercepts were. Our y-intercepts are not. So we have y equals -2 plus or minus the square root of 15. So our y-intercepts are 0, -2 plus the square root of 15, and 0, -2 minus the square root of 15. Let's put all this together and look at a graph. I moved our information up to give us a little more room, and let's get this graphed. It'll be just a rough sketch. So let's start with the center. The center is at 5, -2. So let's say that 5 is about right here. And we'll put -2 about right here. So here's our center. Now our radius is 2 square root of 10. If you use your calculator, you'll find that 2 square root of 10 is about 6.3. So I need to find some points that are 6.3 units away from center. So let's go up. Maybe a point will be here, 6.3 units. And to the right, and below, and to the left. And then I would draw a circle through those points. Woo, remember I said this is very roughly done. Let me see if I can't make this a little bit better right here on the left-hand side. I'm going to erase this part, see if I can make it a little bit better. So it comes around this way. Not a whole lot better, but that will do. So here's my circle, centered at 5, -2. Its radius is about 6.3 units. But let's see if our intercepts seem about right. In terms of our x-intercepts, we have 11 and a -1. So this point right here would be at 11, and this point right here would be at -1. That seems about right. Remember that this distance, according to my rough sketch, is 2 square root of 10, which is about 6.3 units. So if the center had an x coordinate of 5, we add 6.3, that's 11.3. If this is at 11.3, the x-intercept at 11 seems about right. Now let's look at our y-intercepts. If you punch in -2 plus the square root of 15 on your calculator, you'll get about 1.9. Similarly, if you punch in -2 minus the square root of 15, you'll get about -5.9. Let's see how I did here on my rough sketch. So this point right here is supposed to be at 1.9. It doesn't seem quite right, but notice it's positive, so it's not too bad. So this is at 0, -2 plus the square root of 15. And this point down here should be at 0, -5.9, or exactly 0, -2 minus the square root of 15. So those values seem reasonable. Let's do one last example. For this one, notice that the equation is in general form, and this time we're only being asked for the center and radius of the circle. Let me mention that we can tell that it's going to be a circle because we have an x squared and a y squared, and the coefficients of both the x squared and the y squared are the same. In particular, this time they're both a 1. So it makes it nice for completing the square. So let's continue. We're going to complete the square. So we have x squared minus 3x, leave a space, plus y squared equals 1. Notice we do not need to complete the square with respect to y because it's already complete. We only have a quadratic term. We don't have a linear term. So let's take half of -3 and square that. We're going to work with fractions rather than decimals. I'm coming over here to my scratch paper so that you can see how we get the value we do. So negative 3 divided by 2 is half of negative 3, and we'll square it. So we get 9 over 4. So 9/4 is the number that completes the square. So let's add 9/4 to both sides. So our perfect square will be x minus 3/2 squared. We still have our y squared, and that will equal 1 plus 9/4. Again, I'm over here at my scratch paper. 1 plus 9/4 is equal to 4/4 plus 9/4, which is 13/4. So we'll put in the 13/4. And our equation is in standard form. So our center is 3/2, 0. And our radius is equal to the square root of 13/4. Notice I made that radical sign go to the bottom of the fraction, but 4 is a perfect square. So we can simplify this and write it as the square root of 13 over 2. And now this radical sign is just over the 13. I hope you'll go practice working with the equations of circles.